All right. So, just turn my mic on here for a little bit so I can explain some things that I'll be using, not in this video, but probably in a future one soon. Sort of the idea for the functions came to me, and I have some use cases in mind, but I also haven't quite figured out how to write all the other code I need for it. But so, one of the things that sometimes feels weird in Tidal is that continuous patterns, so basically any source of randomness, is going to take a certain amount of it doesn't play well with pattern structure, right? Like you try to add a randomness to another pattern, right? If you do it in a naive way, it'll create technically an infinite number of events, and Tidal just says no, and we'll play nothing, which is a completely reasonable thing to do if you ask a computer to play an infinite number of things. It's a good solution. So, but sometimes I have functions where I want more randomness, and randomness that's not easily encompassing other functions or other pattern styles. Like, for example, I want to choose a set of one use case that occurred to me was I was talking with Clary about he was like super into like these minor 11th chords, which are apparently almost every single note in the key except for the 13th. So it's like basically every note put together in the scale, and that's fun. But there's a whole bunch of variants on 11ths, including like diminished, like major 11ths tend, sometimes leave out the third to make it a little less crunchy, and sometimes there's a diminished variant of an 11th. And what that apparently does is it leaves out the third and the fifth. So what's kind of neat about that is, you're reducing the number of notes that are playing at once. So anyway, one of the things I was thinking about is, hey, wouldn't it be cool to do a thing that takes like a chord as described as a list of, sort of intervals describing how to, get to the next part of the chord, and then just randomly remove one. But the problem with wanting to just randomly remove one is that the easiest way to deal with that randomness is to have it in a pattern somewhere, or to potentially, have it basically like you don't want to use, if you've done much Haskell programming, the I/O monad has ways of doing random numbers, but we're not working the I/O monad. Technically, we're working the pattern monad, and we really want to stay within the pattern monad as much as possible. So it's cool to try and figure out ways of writing helper functions and then feeding them randomness in the form of continuous patterns, and then but having it be well behaved. So that led us to defining this this slight variance on functions that already exist. So bind, bind is the standard, way of taking monadic things and combining them together. And it has this type signature. It takes a container of a type A, a function that takes A's to containers of type B, and then returns containers of type B. Like it sort of unpacks everything and repacks it, packs it as it needs to. If we treat this as pattern A to A to pattern B to pattern B. Cool. So it takes the A's out of the patterns, makes new patterns, and then sort of flattens it all out into one stream of new values. And then similarly, there's fmap. Fmap has a slightly different type because this is based off of the functor type which is another category theoretic thing. But it's different than basically, all monads are functors. And so what fmap does, this is kind of something you've probably seen before in videos of mine, if you've been watching, or maybe you've read in some of my tutorial materials. It's really convenient for patterns because it's a way of transforming what's inside the container, which includes a pattern in this case. And so you basically can take, have a way of taking A's and turning them into B's, and then you can take a container of A's and turn it into a container of B's. And so having functions like this would be great if they worked with continuous patterns and didn't do anything funky. So what that ultimately means is, we basically just define them using the do notation syntax in Haskell and inside the pattern monad, and we use this function called segment. And segment is not as well known as it could be, but it's kind of a neat little thing in that it takes a set of times and then basically a time interval, and then takes the pattern and then sort of chunks it out. And so if we say 1, then that means per cycle it should only have one value, which corresponds to choosing one random value per cycle, which seems like a pretty reasonable thing to do if we want to feed randomness into functions and keep it all inside patterns. And so in that case, these are just these couple of simple functions, and you can see if we look at their types, then we can see that cbind has this type, which is, you can see it's bind, except I flipped the order of arguments because honestly I think this is going to be more convenient, but it's the same, it's doing the same thing. And then if we say, check out cfmap, you can see it's the same, basically the same type as fmap, but specialized to patterns. And this will be only, taking like one value at a time out of here, which is sort of what we want. One value per cycle. And so I think this will be useful for taking those continuous patterns, and so that's what the C is for, cbind for continuous bind and continuous fmap, and then taking those continuous things and then just trying to pull out a single value at a time and use them to do some weird randomness. And this is the function here, this cut n for note, because that's what I'm going to use it for, and it's just like dropping a particular element out of a list. So this is, I'm going to probably finish writing some other code to help me do this, some stuff that involves stack, and then I should be able to do some things that involve like randomly pulling a single note out of a chord, and to experiment with how like chords like a minor 11th sound when you start like trying to make them less dense. And that should be a fun way to experiment with some ideas. And there's other things I have in mind about like generating various intermediate structures that then get compiled to patterns, and having the ability to do some randomness inside, and basically do randomness the way Tidal wants you to do randomness, I think will be really helpful. So that's just kind of a little bit of more Haskell code and explanation, and so that's what I have. That's what I've thought of to do today. Kind of thought the pattern we were playing with earlier with the bass turned out cooler than I even expected. I wanted to try silly things and sort of neat. So in any case, we'll see you in the next video, and until then, take care.